Hello and welcome back. In this video, we're going to be looking at taking the measurement of the radius of a sphere and getting 4 inches, but having that measurement accurate up to 1/100th of an inch. We want to estimate the propagated error in calculating the volume and the relative error as well. So to do this, we're going to go through and first look at our volume formula. And we know the volume formula is 4/3 pi times r cubed. So let's first take the derivative. And again, we're not going to use primes for this notation. We're going to use the Leibniz notation with the dv's. So our derivative is going to be dv dr, and that's going to be equal to 4/3 times 3, which is just 4 times pi r squared. And then if we multiply both sides by the differential dr, that's 4 pi r squared dr. And now we're going to go through and substitute in all of our quantities. And again, I find it very helpful to include units on these calculations. So dv is going to be, that was supposed to be a 4, wasn't it? Not a pi, but a 4. All right, so again, that was a 4 pi r squared dr. All right, so back to dv, that is a 4 times a pi, and my radius we know is 4 inches, and that's being squared. And our differential for our measurement, or our error in our measurement, is going to be plus or minus 0.01 inches. So that's going to be equal to 4 times pi times 16 square inches times plus or minus 0.01 inches, which will be 64 pi times cubic inches with a plus or minus 0.01. So after we go through and calculate this, we're going to have plus or minus 0.64 pi cubic inches. And if we go to a calculator, we will get approximately 2.011 cubic inches, which is a fairly accurate measurement. The next thing for us to do is to go through and calculate the relative error, and that is always going to be the differential divided by the actual calculation times 100%. So for this problem, it's my dv, and we'll use actually the full quantity here. 4 times pi times r squared dr divided by the volume, which we know is 4/3 pi r cubed. And again, that is times 100%. All right, so we can simplify this down, and we will cancel out our common 4s, our common pi's, and we can cancel out the r squareds. That's going to leave us with 3 over r. Times dr times 100%. So it's going to be 3/4 plus or minus 0.01 times 100%. And that actually works out to be precisely plus or minus 3/4 of a percent, which of course is plus or minus 0.75%, which makes this a very accurate measurement compared to the ones that we saw in our notes. All right, so again, we've got our propagated error, which is roughly 2 cubic inches, and then we got our relative error, which is 3/4 of 1%, plus or minus, of course. And that is the error in our calculations based on the measurement of 4 inches with an accuracy of 0.01 inches.